My name is Gina. I am the Clean Program Coordinator. And today we have Karin Kirk, who is a science journalist working with Yield Climate Connections and NASA Climate Change. Karin has done this presentation many times for us, and it is a really fantastic view into the human components of climate change in climate education and energy. So again, feel free to put any questions or comments in the chat, and I will be monitoring that. And without further ado, I'll let Karin go ahead.
Cool. Thanks, Gina. Thanks, everyone, for joining us. Yeah, this is a series of webinars, but this is one that's a perpetually great topic because, as you know, if you're interested in this topic, people can agree about lots of things, but this is kind of the crux of it. Is it human caused? And yet, answer is yes, definitively, without a doubt, completely, 100% if you want to get really into the weeds on it. But yes, it's us. How do we know? How do we teach it? How do we deal with people who aren't sure? Backing up just a sec, Clean, we're here to help you teach climate energy and feel more comfortable and be better at it and feel totally supported. So that's our general mission and why we pick topics like this that we know are hard, because we want to support you and help you do them. So today we're going to tackle, how do we know that humans are affecting the climate? How do we teach it? And what does Clean have that can help you be better at that? So if you were to start at the front page, this is a screenshot. The first banner here as you scroll down is getting started in teaching climate energy, and whether you're starting or you're doing it a long time, regardless, if you go to this explore button, you come to a little fork in the road. Are you teaching climate? Are you teaching energy? And if you go to the climate part, this is not a screenshot, this is just my text here, you'll get to these pages that are the principles of climate literacy. And today we're zooming right in on number 6, on really the crux of it. It is humans. And so that's what we're going to talk about. But the rest of them are here for context, so you can see how the idea of climate literacy is larger than just this one question, although this may be one of the more important questions. Each of these literacy principles, these sort of big ideas, has a page dedicated to it. At the top, you can expand it and see all the sort of nuts and bolts of that. And then you get into just like a nice teacher-based understanding for what the science is, and a little bit about how to teach it, and some ideas for teaching, and some links to some of our favorite teaching activities. So if we jump right into it, is the climate warming? Are we causing it? How do we know? And can we do anything? It's no fun to teach about a topic if we don't at least talk about the solutions. And the lack of solutions can get more pushback. It can make our brains quite uncomfortable and have a harder time wrapping our heads around it. And so it makes it harder to learn. So it's important to pair this with the yes, we can do things about it. This is a really good fit. Granted, this is a big topic in politics, in public discourse, on social media, in our lives. It's if possible, if you set that aside a little bit, it's like an awesome topic for teaching students, especially in light of sort of how we teach science today in terms of the process of science and next generation science standards. And this is really real science. This is not some made up word problems. Students have already heard about it. They're going to come in with their own ideas. They're going to leave with new ideas. They're going to employ that in their lives. It's like really a pinnacle of relevant science. So there are so many ways to teach it that are going to bring that to light. You're using data in so many forms, because there's so much creativity now in scientific visualizations. So you can start with basic graphs and maps, but all kinds of moving things and stripes and spirals. And I work at NASA Climate Change, and the amount of visualizations and now memes that we're working on, we're just always cranking out new stuff to make it more visible and more visceral. So tons of ways to look at the data. But to engage a little bit in how the process of science works, so you're not just hearing this handed down from on high. So immersing students and looking at the data, doing jigsaws and things like that, where they're tracking down different elements of the bigger picture, and constructing some of that knowledge for themselves. Some of the social pushback on scientific issues right now is that they're, don't tell me what to do, you so-called experts, right? So if we immerse the students in doing it, then it's less of us telling them what to do and more them learning the process of science and experiencing this evidence for themselves. The only thing we really don't recommend is any kind of debate, whether it is or it isn't, because it is. Plenty of other things you can debate in terms of solutions and things like that, but let's not debate this one because it's really very tight science. So an easy question to start. Well, the easier question is the planet warming. Most people agree on this, but not everybody. But I think it's important to build here with our evidence. So we've got really good instrumental records. This is NASA's, but there are many agencies that collect this data, and you can see really starting kind of late 70s, early 80s, kapow, it gets warmer. This is land plus ocean, and it's a smoothed out average. The red line and the black is sort of the annual global mean for the year. So if you like science data, if you like graphs, if you like the instrumental record, this will satisfy you. Plenty of people don't like that. They go, well, there's not enough thermometers, or well, what about going farther back in time? You know, there's always the well, but. Okay, fine. Let's just talk to the Earth itself. What's the Earth telling us about what's going on? Let's start at the Arctic sea ice shrinking massively. Hey, look, South Pole, same. Okay, what else is going on? Oh yeah, glaciers in the mountains. Yeah, they're also shrinking. So we have all this ice doing the same thing, getting smaller. And so if we were to look at like Earth as a system, we'd say, okay, the cryosphere, icy frozen parts of the Earth, we could throw in permafrost in there, all saying, yeah, they're all that ice is shrinking. Snowpack is shrinking. All those things. Who needs a thermometer? The icy parts of the world are saying, hey, it's warmer. Okay, what about the biosphere? What about the living parts of the world? So we can look at the timing of things. And this is something probably most people have a sense of. Does it snow later? Does it snow never? Does the snow melt earlier? Does the fires start sooner? Lori in Olympia, do the fires go longer? Can you feel it in your gardens or in your farms? So that's phenology. Species are moving around. They notice this, they feel it, they're responding. So we have migration timing is different. We have ecosystems moving and forests changing. So the living parts of the Earth are telling us the same thing as the frozen parts. Yes, it's warming. There's my tomato. You didn't used to be able to grow a ripe tomato in Montana. Now it's a piece of cake. Everyone can do it. Side growing season's much longer and warmer. A hydrosphere, we're going to see the same themes here. Okay, the ocean heat content is increasing. Most of that extra heat's gone into the ocean. Storms have become more intense. Sea levels rising. So again, more signals. No thermometers needed. Actually, yes, for ocean heat content, we need a thermometer. What about looking backwards in time? Ice cores, tree rings, corals, marine sediment cores, lake sediment cores. Tons of evidence if we look backwards to put some context in it. So without using thermometers, we know a lot about the Earth and how it's warming and where it's warming and what that's causing. And so I think this is important because we don't want to just be like only using sort of our traditional ways of measuring temperature. It's important to know that it's a holistic Earth-wide response to the fact that the entire Earth is warming. So I think that's a useful introduction to say that it's really bigger than just any one data set. Okay, so if you want to teach that, Clean has lots of stuff, and I pulled out just some screenshots of a few things. So you can talk about glacier shrinking, just what I was talking about, and that's sort of a visual thing. You can do the same over here, Arctic sea ice losing its bulwarks, the same thing. It's a visualization showing year by year. This is the NASA GISS surface temperature analysis that I was just showing you, and there's a few different formats in that, and that's updated constantly. Phenology, this is a unit that's made up of Clean sort of assets about the timing of the seasons and the ways that plants and animals respond to that. And this one uses ice core data, Earth's changing climate, so we can go backwards to get a bigger context. And these are just a few examples. You can find lots of stuff that's going to fit the format and interests of your students, just a sampling. But let's move to the bigger question. What's the deal? Okay, yeah, it's getting warmer, but is this a natural thing or whatever? And so again, this is where students, I think, can really have a rewarding time jumping into this. It's a pretty complex question, but certainly a really worthwhile one. As we go into this, I'm the first one to sort of want to blame Exxon in particular, but this is not so much blame, but attribution. Like from that scientific point of view, can we really tease out the cause here, the attribution? So not to make it the thing. So I'm going to try a metaphor here, because when we talk about climate change, then instantly everyone kind of gets into their camps. And so I'm going to talk about a metaphor. So you wake up in the morning, you walk outside and you say, the grass is wet. Why is the grass wet? So either use the chat. I can't see the chat too well in presentation mode, but use a chat or whatever. Think about a couple, like how could the grass get wet? Think of a few reasons. I'll give you like 30 seconds to just jot them down in chat or otherwise. Well, how could that be? How did the grass get wet? Or you can call them out, or maybe I can't see the chat. I see the chat, but I don't see things in there. Anyway, yeah, so you're probably realizing there's several ways the grass could get wet, right? So, whoopsie. It could have rained overnight. Your sprinklers could have gone off. Maybe they're automatic or something. Maybe someone else in your house turned them on. Maybe there was dew. Maybe it didn't actually rain. Maybe the neighbor had their sprinkler going on and the wind blew it over. Maybe there's some like pipe uphill from you that sprung a leak and is running down into your grass. Maybe the stream nearby is just overflowing, so the edge of the grass. There's lots of reasons why the grass is wet, and those are all valid reasons, all totally legit. But some of them are natural and some of them aren't, right? And so people say, well, climate change has been natural, was natural in the past, and that's the end of it. I like this grass analogy because it's like really disarming. Like we know that the grass can get wet for lots of reasons, both human and natural. But just because there are natural ones, does that mean the grass must be wet due to natural causes every time? Like, does that mean that sprinklers like don't even exist because rain also exists? You can see that that's a very silly argument. So just because, whatever, like Cretaceous was warm doesn't mean that burning fossil fuels and increasing atmospheric carbon dioxide doesn't also warm up the planet. And so this is a nice pedagogical technique to sort of sidestep the emotion-laden territory. Just take one step exactly sideways, teach the same concept without the context of all the implications. And so, yes, sprinklers exist and it also rains. Bottom line. Okay, so the same applies to climate. Okay, but what about this? We're coming out of an ice age. Like, oh no, it was cold and then it got warm. But sure, it was cold, it got warm. That's all way in the past. Okay, this is, sorry, a very poor resolution, but this is around 10,000 years ago when things kind of leveled off and stopped warming in terms of the ice, as far as the ice age cared. And then here's the current warming. Is this related to that? I'm like, no, first of all, it's straight up. Second of all, it started all out of the blue very recently. So no, yes, we have come out of an ice age. Are we still? No, totally different thing going on there. But it's a natural cycle, like ups and downs and ups and downs. Like, yes, it's done that before. Again, you could use a sprinkler analogy, or you could look at a graph like this and say, sure, it did go up and down, but look at today. Does that look like a natural cycle to you? No, that looks like an anomaly or something that's completely different than the natural cycles. And you could ask students, in what ways is it different? Well, it's more straight up, which means it's happening faster and it's way bigger. So from this, I like to say that humans are a geologic scale force on the planet. We can change the planet more than an ice age has, and in a shorter time. So humans are part of, our agents of geologic change. Okay, another thing you might hear is correlation and causation. Correlation isn't causation. So you can look up some spurious correlations. It turns out that, per capita cheese consumption by year, correlates with how many people die by getting wrapped up in their bed sheets. It's kind of like bizarre, right? But it correlates, sure. That's a logical fallacy in the case of climate change, because we have both. Like things that are correlated also have causes, when it's a good fit. And so this is just a logical fallacy that people throw out there. And you go, well, fine, do we not have causation? Of course we do. Causation is that here's an innocent looking CO2 molecule. they trap heat. They block outgoing radiation coming off the planet. We've known this since the 1850s. My goodness, this is not new science. And it's only ever been reinforced. The idea that carbon dioxide traps heat has done nothing more than become a stronger and more solidified idea. Furthermore, if we know that carbon dioxide traps heat, here are human carbon dioxide emissions. This is not subtle. This is 1.5 trillion tons of CO2 emitted since 1850. And here's the different fossil fuels that have caused it. This is massive change. Then we can look at the isotopes of that carbon and say, this isn't just random carbon like coming out of peat bogs or whatever. This is very old plant-based carbon, and it's chemically distinct from more recent carbon or carbon coming out of the ocean and other places. So fossil fuel consumption is pumping that carbon dioxide into the atmosphere. So that's our causation. So CO2 traps heat, we're adding CO2. That's that. So correlation means like how well do things match? And correlation becomes a pretty important part of this puzzle. So here is the first graph of fossil fuel consumption. And here's our second graph of carbon dioxide increase. This graph goes back to the mid 50s. If we kind of line them up, because to correlate them, they have to match, the time scale has to be the same. And then you can start to see like some pretty amazing things. Granted, you could make the slopes of those lines anything you wanted to, right? Just by scaling your graph. But nevertheless, yeah, those two are both going up. The timing matches, the magnitude matches, the scientific sort of essence of it, the fact that CO2 traps heat also matches. So the correlation is actually looking pretty important in this case. And now let's get really into it. So what about other correlations? We know, like from our grass getting wet idea, that there are lots of ways that the climate can change. And so let's go through all of them, like our grass analogy, like did the sprinkler run? Like did the stream flood? We can look at these things. We measure all these things all around the Earth system. And so this is where you really get into the nitty gritty. And so this is the kind of stuff I would do with, high school and up, or you can have sort of different versions of it for younger students. But it's helpful for our own understanding also, because this is really the crux of it from the science point of view. These graphs are all from the National Climate Assessment, which is a wonderful place, very much written for human beings, not just scientists. And so that's where these graphs are from. So here's our temperature record from 1870 to the present. So you see kind of like wiggly up and down again till around late 70s. And then a significant up. So what else on Earth could match that? So I'm just making a little matching game. I just took these out of the report. So is it the sun? Yes, it's the sun. The sun is warming the planet. Okay, is it? We have data that goes way back on the sun. So the sun does have a cycle, has a sunspot cycle, and it does have, some very minor trends up and down, things like that. But if you look at this part of the curve, the last 50 years, and this part of the solar cycle, do they match? Are they correlating? They are not. So the causation could work, but the correlation does not. So it cannot be the sun. We've got very good measurements on that. It's not the sun. Oh, what about volcanoes? I live near Yellowstone. People like to say, well, if Yellowstone blows, then it doesn't matter. And it says, well, what if Yellowstone doesn't blow? Then it still matters. Anyway, volcanoes by and large cool the climate from aerosols and basically tiny little droplets that go way up into the stratosphere, and they're like little reflectors, and those reflect sunlight. And so these are major volcanic eruptions over this same time scale from the temperature record. Do those match? Nope. They go in the opposite direction, and the timing is totally not matching. Okay. Volcanoes do also put out carbon dioxide, and it's a tiny amount. It's like 1% of what humans put out. So it's not that either. Okay, what about those so-called natural cycles? So here you have things like El Nino and La Nina and other different oceanic cycles. Do those match? I mean, they're interesting. There's definitely cycles, but are they matching the trend? They are not. And so I think this is interesting too, in terms of helping students understand that there's some cycles going on in here, but there's no trend. It's pretty flat. That's that dotted line in there. Whereas if you look at what's actually happening, you see cycles as well as trend. Great quantitative reasoning here. Okay, this last one is anthropogenic. That's us. So this is mostly our CO2 emissions, but also things like burning forests and turning forests into crops and things like that. Changes in land use. And so you see, whoa, yeah, that actually matches pretty good. It's not only the right timing, but it's also the right shape. So I think it helps to rule these other ones out. And this is a great kind of thing for a jigsaw. There is a very lovely visualization by Bloomberg. It uses the NASA GIS data, and it walks through all these things in terms of, and they're lovely kind of animated versions of the graph. And so if you like this idea, it's in the Clean collection. And hopefully by the time I give this webinar at NASA, we're going to have our own version of it because we like this idea too. Okay, so how can you teach human attribution? There's lots of ways. This one up in the upper right does a similar approach. It goes through all the different things that are currently happening and measures them in comparison to what we're seeing. Here's a video interviewing scientists talking about nitrogen oxide, nitrogen isotopes, to talk about what, where greenhouse gases are coming from, why we know they're coming from human activity. These ones, this involves a role play. And then this one sort of is a multimodal kind of thing. They have play a game, they use analogies, and they use graphs to sort of wrap their head around the problem. So lots of ways to do it. These are, again, just a few things I pulled out from the Clean collection. There's some pretty big science in there going through those attributions and correlations and stuff, but it's doable. And I think it really does help to cross off those other things. It's like when I try to pick out like a new backpack to buy, I have to eliminate like every other option before I can be comfortable with the one I picked. And so I think ruling things out helps students feel better about it. When in doubt, there's always the gut feeling for people that are not sure. Look out the window. Not that your window view looks like this, I hope. But the presence of the human footprint is not subtle. No matter where you are, no matter what way you're looking at it, the presence of human activity is really huge. Do you think that maybe we did all of that, all these people, all these emissions, all this industrial activity, all this change in the world, and had no effect? Like, does that really wash? And I talk to voters a lot. I engage in a lot of sort of local grassroots energy advocacy. And when in doubt, the gut feeling thing works really well because, like, nobody thinks that we're just leaving this pristine footprint on the planet. Everyone gets on some gut level that we're making a big impact. So if the science doesn't seem like the way to go, you can ask people to do a gut check. What do people think? I think it's important to reflect on where people are in there and how they view this. It might modify the way you teach it or how you approach it. These Yale climate opinion maps are really super useful. They're updated continually. The current ones are from 2021. You can pull down different questions and look at this by states, by counties, by congressional districts, by metro areas. And you can, I hope, as you're doing right now, you can find your county and go, yeah, that matches what I think, or maybe it doesn't. Or what's going on elsewhere in the world? What are these blue places that are not really thinking that global warming is even happening? And like, why would those be blue? Well, perhaps because those are places where fossil fuels are coming from, at least for sure here in North Dakota and Wyoming. Has a lot to do with people's political persuasion also. But these are really useful, so you can sort of know your audience. The crux of the question though here is the same thing, but now we're looking at, is it human caused? And you see the map is a lot bluer, indicating like we're not so sure. And again, you can look at geography and look at why it differs where. But I think this is very important to know your audience and know what they might be thinking about this question before you teach it. On the website here, you can pull down many other questions. Especially interesting are the ones about solutions, because even if this is the biggest amount of disagreement, this particular slide, but then you find more and more agreement when you get into the solutions. So maybe you don't even have to worry too much about this exact thing, and just you can kind of fast forward and get into the solutions, which have universal benefits. That is another webinar. How's our opinions changing over time? Now, this is actually an awesome graph. That would be more awesome if the green line were really, really high. But what's happening is that this green line, yeah, it's really slow, but it is going up. Like, sure, it goes down, but the trend, we were just talking about that, right? Trend is unmistakably up. The no line has kind of no trend. It's like 7, pretty much, right? And so if you meet like the hardcore climate denier who's really, really hardcore, okay, that's one of the 7% of Americans. They're not going to change their mind because that line is flat, baby. But it's only 7%. So 7 and 54 do not add up to 100. So where is everybody else? In the middle. So that middle zone is a really good target audience. If you have someone who's not so sure they're in this middle zone, no harm, don't worry. That's our job as educators. Are people that you meet going to be in the 7%? Maybe, but it's unlikely. There's not too many people. So, and that line isn't really changing. But so we're pulling people from this I'm not sure, and we're adding them to the yes. That's basically what's happening because of all of you and all of us working on this issue. Scientists, yeah, boring. We're totally aligned. We have been all along. This idea of consensus has kind of been attacked a lot, so I don't teach it too much, but yeah, scientists completely agree on this. That's been known and measured in lots of different ways for a long time. But, it's inevitable you're going to get some pushback. You're going to get people that are not so sure, or you hear some of the sort of what about kind of things. And I just want to touch on this quickly. And so sadly, right now, we're hearing it a lot in the sort of political sphere. I live in a red state, and so I hear a lot of this from the Twitter feed of some of our elected people. And it's good to know what's the refrain these days, because then it can help your own reasoning, and it can also prepare you for who you might be talking to. So what you want to do, let me actually go back here. You want to address it. You want the students to have seen these myths before they're done in your classroom, so that it's like they're inoculated or vaccinated, right? They have a little pre-exposure and they know what the resolution is. Don't avoid the myths because they need to see them, but don't reinforce them either, because then they'll get this sort of familiarity effect. So you want to spend some time inoculating your students to some of the more popular myths. You don't want to overemphasize it, but you do want to do it. So you emphasize the facts. You fight these sticky myths with equally sticky facts. That's what we're working on a lot at NASA, is making cool memes and things that are actually really compelling and interesting, that are going to be memorable. You do want to mention the myth only in the sense of saying, here is the myth, very well labeled, so that they're in your sort of cognitive uptake, that's getting filed in the myth category. And then the fallacy thing is interesting. You say, well, why is this wrong? Is it because the math is wrong, or they cherry pick the data, or whatever? The experts they use aren't even experts, So if you pick apart why, that can be a very satisfying thing for your brain. Just like when we looked at the correlation thing and we saw that nothing else matches, you're like, okay, I'm going to put that to rest. So the fallacy approach can do that also, point out why it's wrong. Clean has a bunch of activities. More and more this kind of thing is being taught, sadly, because scientific misinformation is becoming more and more common. So it's really important. So these are generally kind of more upper level students, but these are great activities that take pieces of misinformation and have students dig into them, or give conversational strategies, or this one, how to talk to people. I really, really like this one. It gives you a little video and a sort of structured outline to how to talk to people and really how to listen to people. So I'm a big fan of that approach. Managing this in your classroom, we have a whole page with lots of support and lots of examples about how to do this in your classroom. Like I said at the outset, we are here to support you. This page is written to help you feel more comfortable and give you tools. And really, it doesn't end up being that bad, but it's nice to have a support page if you have a specific question or just want to sort of prepare. And so we even have sample dialogues in here, so you can go through and talk about how you can frame and how you can diffuse conflict. And a lot of these I've developed from, I do tons of conversation with voters and I've had lots and lots of conversations. So many thousands of conversations of practice have helped inform some of these strategies. Then there's the emotional pushback. You know what? Fine, the science is true. You're very convincing, but I still hate it. So that's easy. Very quickly move to solutions. We don't need people to dwell in a cognitively, emotionally painful place, especially not now, because we've got so many cool solutions and they are coming on fast. And so people get excited about this stuff. You know, electric cars are cool, clean energy is cool, efficiency is cool, whatever. There's lots of cool stuff. And so that our brain really loves. So you can kind of feel out your audience and you'll get a good sense for when it's time to move on to the cool stuff. Clean has tons of stuff. This is just a screenshot of the collection, and there's this humans can take action section. Lots of things, and you can start sorting that by audience and whatever else. So yeah, emphasize that as soon as you need to. And there's 2 of these sort of climate literacy principles pages that go into that. One is about humans taking actions. The other is about on energy literacy, how we make energy decisions. Those 2 are going to they're just like 2 paths that are going to lead to the same thing. They're going to lead to the same resources, similar anyway, or some will be the same in the clean collection and even in public policy and everything else. They're going to lead to the same place because we reduce climate change impacts by, not impacts, sorry, we reduce climate change, we reduce emissions by tackling the energy system. So 2 sides of the same coin. Yes, at the bottom of both those pages, you'll see some activities, and then you can jump into the collection and search from there. So that's a place to go look. And that wraps us up, like a little bit over time, sorry. You can get involved. We're very open and friendly. We've got these resources. We've got a cool newsletter that's very topical, where you get a little dose of fresh insight that's topic driven. So it's talking fires or hurricanes or climate policy or whatever. If you've got good resources that are online and free, please tell us about them. We'd love to review them for the collection. Clean Network, we've got groovy phone calls once a week where we hear from experts or talk to each other, and it's just nice to have camaraderie. Teacher Ambassador Program, we would like to support you in the climate and energy education you do. If you have cool things you've done, you can make presentations. And then yay, we're face-to-face at workshops and conferences and stuff, and we have a pretty big presence there. That's just a look at where you can find all of the things that we do. And then we have our upcoming webinars. So there's 2 to come still, about elementary level students, and then climate empowerment. And I love that. So it's not just doom and gloom. What can we do and feel good about? So that wraps it up. I am going to stop share and see if we have any questions or if anyone has any feedback they want to add.
Thanks, Karen. And yeah, I just put the link to the other upcoming webinars and the Get Involved page and a variety of other links, as you can see in the chat. So feel free to check those out. We have been recording this, so if you want to rewatch it or see again what Karen had mentioned in the slides, that will be posted in the next week or so on that webinar page. So you will have access. We got a question from
Lego. No, I don't think we do.
I
don't think there are.
I don't think so.
But it sounds like what we need is you can submit one. You can need to make that and share it with all of us.
Yeah.
Because that's a cool, who doesn't love Legos?
Yeah. So hi, I'm Andrea, and I can't take credit for the Lego chemistry and atmosphere and science. That was developed by researchers at the Massachusetts Institute of Technology.
Mm-hmm.
And they have a whole subset group at MIT. Let me look up the name of them. That is called the Edgerton Center.
Okay.
And so I'll just post the link.
Oh, great.
And they even did a collaboration with public broadcasting of doing science with Legos.
Awesome.
Oh, cool. I have not heard of that, so that's good to
yeah. We'll look at it for the next review cycle. Thank you.
Yep, but I don't know if I don't want to add more work for you. I just thought if you had also had some Lego teaching examples, then I would be happy to borrow them.
Right.
Yeah, I just searched. There wasn't anything off the top of my head, and in the search, there's nothing coming up. But I agree. Maybe in the next review cycle or two.
Yeah. You're going to add work for us. That's what Clean is here to do. We get paid to review things and add new things to the collection all the time. So you're giving us job security.
Oh, good.
Good question.
Mm-hmm.
Well, I'm not seeing anything else in the chat.
Okay.
Again, this is going to be posted. I also meant to put in the chat, this is our email, team@colorado.edu. So if you do think of anything else, feel free to give us an email or send us an email and let us know. And we really appreciate everyone being here. And Karin, thank you again for another amazing presentation. Always very informative.
Oh, well, thank you. Thanks, Gina. Thanks, everyone. And yes, onward to more climate solutions. Let's hope.
Thanks, everyone.
Thanks, Andrea, for the comment. Bye-bye.
Bye.